All right, ladies and gentlemen, so today we're going to continue with graphing, and we're going to be looking today at absolute value functions. And you need to know that absolute value functions, let's try that again. So you need to know that they form a V. And it is definitely a more point, unlike your quadratics where they formed the U and it was a curvy. This is going to be straight lines. So let's take a look at this. So I'm going to pick some values. I'm going to do -3, -2, -1, 0, 1, 2, 3. Right? And what's going to happen, we know that the absolute value means it has to be a positive. So the absolute value of -3 is 3. Absolute value of -2 is 2. -1 is 1. 0, 1, 2, 3. This, by the way, we talked about this the other day. It's called a parent function because it is it's the most basic one that you can have. There's no other numbers in there. All right, so you also should see a pattern over here in your y values. All right, so let's take a look at what it's going to look like. So -3, 3, 2, 1, 0. Right, you can see that nice V shape here because they're coming in at straight lines and then going out as straight lines. And we're going to label this f of x equals the absolute value of x. All right, not so bad. So over here, now we're going to do the absolute value of x, and then we're going to add 2 to it. So I'm going to use the same values just so that we can see that nice V shape. You should still see a pattern. All right, so over here, this means the absolute value of -3, which is 3, plus 2. So that's going to give me 5. Absolute value of -2, which is 2, plus 2, which is 4. This is going to be 3. This is going to be 2. And now we're going to go back up again. 3, 2, oops, that does not make sense. How about 3, 2, 3, 4? And then 5. So over here we have -3, 5, 4. So if you notice, it looks basically like the one we just drew, except instead of going at the origin, it's going up 2. So f of x equals absolute value of x plus 2. All right, so this is moved up 2 from the original, from the parent function, because we're going to talk about that a little bit later. All right, now we're going to do the absolute value, so different, because here only x was in the absolute value signs. Here I have a whole function inside there. So -3, -2, -1, 0, 1, 2, 3. So again, this means -3 plus 2, take the absolute value. Well, -3 plus 2 is -1. The absolute value of that is 1. Absolute value of -2 plus 2, well, that's 0. All right, absolute value of -1 plus 2 is 1. And absolute value of that is 1. 0 is going to give me 2. 1 plus 2 is 3. 2 plus 3 is 4. 3 plus 2 is 5. All right. We did end up seeing a little bit of the repeating here. I just didn't go out far enough. So when I do this one, we're going to have -3, 1, -2, 0, -1, 1, 0, 2. Notice, though, with absolute value functions, we still get our nice V, is that we cannot have, our y values can never be negative, because we know in an absolute value that has to be a positive answer. So if I label this f of x equals x plus 2, and again, if I compare it to my original, my parent function, instead of going to the origin, this one is shifted to left from parent. All right, so those are absolute value functions. Now we're going to talk about something called piecewise functions. Piecewise function. So the graph is broken up into pieces. And it's with 2 or more functions. All right, the two functions. So we have 2x plus 6, x has to be less than 0, and x minus 6, x is greater than or equal to 0. All right, well, what does that mean? So I'm going to create two different tables. xy, xy. All right. When I do those, right, I'm going to do for this one, it's telling me x has to be less than 0. So the numbers that I pick have to be less than that. So I'm going to start with 0, and I'll explain why. -1, -2, -3, -4. Right, just like if I were to graph it on a number line and you'd have to put and start here, I'm going to do that, but this is going to be an open circle. Right, just like we did with inequalities. So if I put 0 in, right, this is 2 times 0 plus 6, so that's 6. This is -2 plus 6, which is 4. -4 plus 6, which is 2. -6 plus 6 is 0. And then -8 plus 6 is -2. All right, so I'm going to start that. So this is all that I'm allowed to have here. So I'm going to have 0, 6, but I'm going to make it an open circle. I'm going to have -1, 4. I'm going to have -2, 2, -3, 0, -4, -2. So that one is coming down like that. Okay, well, for the other part, right, this one is greater than or equal to 0. So I can have 0 here, but this time it's going to be a closed circle. And the numbers that I have to pick then, 0, 1, 2, 3, 4, have to be greater than 0. Okay, so this is going to be 6 minus 0, which is 6. 6 minus 1 is 5. 6 minus 2 is 4. 6 minus 3 is 3. 6 minus 4 is 2. Well, I already have a point here. So what I'm going to do that is I'm going to have kind of inside the circle I drew, I'm going to have another point. Because that's telling me it's a function because it technically only hits that part of the graph one time. So it's 1, 5, 2, 4, 3, and then we're coming down like this. You do need to label both of those. So this was f of x is 6 minus x, is greater than or equal to 0. And this part was f of x equals 2x plus 6, x is less than 0. Right, so it's really just doing the same, you're doing two and putting them on the same graph, making sure you're paying attention to your restrictions over here. All right, so this one, we're going to have xy. For this one, x has to be less than 1, so I can start at 1, but again, it's going to be open. And then I'm going to have 0, -1, -2, -3, I'll do one more, -4. So 3 minus 2 times 1 is 2, so 3 minus 2 is 1. 3 minus 0 is 3. 3 minus a -2 is really 5. Then this is going to be 7, 9, 11. All right, so when I put this one on here, it's going to be an open circle. And then we're going to have 0, 3, we're going to have 1, 5, 2, 7. The other one doesn't even fit on the graph, so we're going to kind of graph it like that. And then for my second function, so we're going to have xy. This time I have to be greater than, but I still have to start at 1. But again, it's going to be open. 2, 3, 4, 5. We'll see if we can get them to fit. So this is going to be -2 plus 3 is 1. -4 plus 3 is -1. Right? Let's see, -6 plus 3 is going to be -3. Then -5 and -7. So again, we're still going to have that open circle here. We're going to basically have a hole in our graph. 2, -1, 3, -2, 4, no, that was 3. Sorry. How about 3, -3, 4, -5, 5, -7. So it does end up being a nice straight line, except it has that big hole in the middle. And you should absolutely label yours. I'm being lazy right now to save some time. All right, one more. Let's see if we can get, so here, as soon as I see this, I know it's going to be U-shaped. Okay, I know that. So I'm going to start with my two tables, x, y. I have to be greater than 0, so I'm going to do 0, 1, 2, 3, 4. This is going to be open. All right, so 0 squared is 0, plus 2 is 2. 1 squared is 1, plus 2 is 3. 2 squared is 4, plus 2 is 6. 3 squared is 9, plus 2 is 11. 4 squared is 16, plus 2 is 18. Definitely not going to fit all those on the graph, but that's okay. So when I graph that, I'm going to have at 0, 2, I'm going to have an open. And then I'm going to have 1, 3. I'm going to have 2, 6. And that's really all that I can get. But I know it's going to be U-shaped. So when I draw it in, I'm going to try to make it look like a U. Over here, we're going to have x, y. This time it's going to be a closed circle, and we have to be less than 0. So 0, negative 1, negative 2, negative 3, negative 4. I'm really going the wrong way, but that's okay. So 0 minus 1 is negative 1. Negative 1 minus 1 is negative 2, negative 3, negative 4, negative 5. So we're going to have a closed circle, 0, negative 1, and then we're going down. And again, you should label yours. Right? Any questions? Bring them to class and have a good night.